Very good afternoon, everyone. So in this session, we are going to discuss about the another, you can say, Spark, very important topic called dataset. In the previous many lectures, we have studied about what is an RDD, what is a data frame, and we have seen many of the operations, high-level order functions in the RDD as well as in the data frame. So today we are going to discuss about the dataset. So when we say data set, we can say that this data sets is actually a high level API, just like the data frame. Okay, so this is also a high level API for your structured data. Okay, that we can say that means this is like an extension of your data frame, because in data frame we talked about the structured data, different CSV format, Parquet format, and similarly this data set is also a high level API for the structured data. You can say it's an extension of data frame, and this data sets is actually, you can say, is again, you can play with like a typed and untyped. So now in the dataset API, the core of your dataset API is your encoder. So encoder is very important thing in the dataset framework. Encoder is actually, you can say, responsible for converting between your Java objects and tabular representation. So encoder is the main entity inside the architecture of the dataset, which is responsible for converting your Java objects into the tabular representation. Okay, so now tabular representation, this tabular representation is actually stored using the Spark internal you can say tungsten binary format. And we are going to discuss about this tungsten framework in a separate session, uh, because this tungsten and the catalyst optimizer are the advanced topic, and it will boost the speed and processing of the data set and the Spark. That is why data set come into the picture. So now this tabular representation is actually stored in the tungsten binary format. Now this data set is actually a strongly typed, you can say strongly typed and immutable collection of objects. Okay, and these objects are mapped to your relational schema. That means you can say map to the relational schema. Now this data sets provides the benefits of, you can say, provides the benefit of RDD as well as the Spark. So when I say RDD, I mean to say that in terms of RDD, they are, you can say, strong type language or strong typing, and it also provide you the lambda functions. Okay, so this is the benefits of the RDD, and similarly the benefits of your Spark SQL or data frame. So I can say Spark SQL. Then in terms of Spark SQL or data frame, it is optimized, having the optimized execution engine. Right? So now the beauty of this data set is that it is having the benefits of both the RDD as well as the data frame in terms of Spark SQL. Okay, now this data set is actually, you can say, constructed from your Java or JVM object, and you can manipulate it using your transformation, like similarly what we have done earlier, like map and then filter, or you can say flat map, and many other transformation we have studied. You can use those transformation in this also, and basically it is used with a language called Scala and Java. There is no Python. That means there is no Python or R language for this dataset. That means it is not supported. You can also consider this, the object of the data sets is equivalent to your RDBMS. Okay, this is equivalent to RDBMS, but now it is having a like with the rich optimization. Now in the data set, what happened? It actually internally it automatically optimized both your storage and as well as the computation. And for this optimization, the tungsten framework will be used like for storage, because it is using internally a binary format, and the computation we have the catalyst optimizer, and these are very well used in this optimizations. And this optimization is something like for like your data frame, because data frame is internally uses the catalyst as well as the tungsten framework. Now the question arises, why we have to use a data set? Very interesting and very important question is why we have to use why data sets. Now we have to use the data set, and we should use the data set to overcome the limitation of your RDD as well as the data frame. I'm writing in short. Now when I say data frame, what I mean to say that shortcoming, that means in dataset we don't have or no provision of your compile time type safety. Okay, so there is no provision for compile time safety. That is why this dataset introduced the compile time safety. So when I say compile time safety, what I mean to say that it means that data cannot be altered without knowing its structure, So this is a compile time. And in terms of RDD, when I say what is the limitation of RDD, the limitation of RDD, it removes that no automatic optimization available in the RDD part. We have to write the code. That means we have to do manually if we need this optimization in our program. So these these limitations are removed by the data sets, and because of that, data sets are more powerful in terms of optimization, in terms of you can say space, in terms of processing and computation. So these are the reason we should use the optimization. So now let's see some of the features of dataset. So what are the features of dataset? The very interesting and first feature, we can say that it is having a static typing and runtime type safety. Okay, just to understand this, so let's say there are two kinds of error. We have syntax error and we have analysis errors, let's say. Okay, these two types of error we have, and on the top we have, let's say, SQL function we have discussed. We have talked about the data frame, DSL languages, and now we have a data sets. So now if I say SQL part, the syntax error are known at runtime, and similarly analysis error are also known at runtime. But the data frame, which we have discussed in the previous sessions, the syntax errors are known at compile time, and the analysis error which is at the runtime. But the data sets, the syntax error are similar to the compiler, it is at the known at the compile time, and even the analysis error can also be known at the compile time. So this is very highly typed language. Now next feature of the dataset is like it provides you the high level of abstraction. You don't need to understand the complexity of saving and computations and how it optimizes has been done, but you just merely have to call the transformation. So it is having a high level of abstraction, and also the custom view into your structured and semi-structured data. So it is also giving a support for structured and semi-structured data. And the API which we are going to use in the dataset are very easy to use. The easy to use or easy of use API is available in the dataset with the structure. This is very, very interesting and very important to understand. And parallelly, it is also known for the performance and optimization by different frameworks. It also support internally like Tungsten and Catalyst, and it is interconvertible. When I say interconvertible, I mean to say that it can convert the type safe. That means you can convert your data set to any untyped like data frame. And how we can do that? We can do this with the help of, like, we have a function called 2ds, and then in this 2ds it can convert your data type or a data frame into data set which is completely a typed language. Or you can call 2df, where you can convert it to the data frame. Okay, now with this dataset, you can achieve your computation very fast. So I can say it's having a faster computation, and it uses very less memory consumption because internally it is using a tungsten framework in a binary format, internal binary format by the Spark, less memory consumption, and you have a single API for your Java as well as Scala code. The make it very simple, and the features like lazy evaluation is also there, which we have discussed in RDD, and you can catch some of the bugs at compile time, okay, that are not that are not caught by the data frame, which we have discussed in the last session, okay, till the runtime, because data frame will come to know about this bugs at the runtime, not at the compile time. So this is the beauty of the data sets. So just I want to move to the little one beautiful diagram. Let's say we have a data set. This is our data set, right? And this is our encoder, and this is your query execution, and this is your Spark session. This is your Spark state, and this is your Spark optimizer. This is your logical plan for executing your query in the data set, and this is your DS dataset internal. Now you have encoder, query execution plan, and Spark sessions are very important component. So that means, and the session Spark session will have a session state, and then you are using Spark optimizer. So that means with this diagram, I can conclude that the data sets consist of three elements. Now first one is your query execution. So when I say query execution, that means this query execution is like I'm talking about the past unanalyzed logical plan of your structured query. Second important part of this dataset internals are like it's an encoder. So encoder is your, you can say, which converts from byte JVM object to your tabular data sets. Okay, tabular representation. This encoder is actually contains the types of records for your fast serialization and the reverse process of deserialization. That is why converting the JVM object into the tabular representation is quite easy. And the third most is your Spark session, which we have discussed lots of time. Okay. Now this data sets are, if we see this diagram, so that means these data sets are like your data frame. Okay. So these are like your data frame. Like data frame, the data set also uses your Catalyst query optimizer and your Tungsten framework to optimize your query performance. And we are going to discuss this query Catalyst query optimizer and Tungsten in a separate individual sessions. Now this data frame came into the picture like in the 1.0, but with the data set, and when I talk about the data set, the preview part came in the existence of Spark 1.6 version, where you can say it was a preview of the data set was available, and this is used for experimentation features was there. But with the version of Spark 2.0, it is come into the use as a complete data set. Okay. So in the data set, we have syntax as well as analysis check. Both are done at compile time, as just we discussed. And if you remember the storage level, different storage level, what we discussed in the RDDs. So that means in this default storage level for the data set is memory and disk. So this is your default storage level. So just like an RDD and data frames, it is also having lots of operations and which comprise of transformation and actions. So now with all this, we can say that this data set, DS stands for data set. The data set is a strongly typed, immutable collection of domain object. Why domain object? Because dataset internally is having their domain specific language, DSL is there, which is actually untyped. So when it is an untyped, that means it is, I am talking about the data frame, and this can be represented as a data set, and I am talking about row. So this is your untyped data set. Untyped data, which is equivalent to your data frame. Here the rows are, can say, collection of generic untyped JVM objects, right? Now when I say untyped, it means I'm talking about data frame, but the representation will be in the data set, but and this row will be your row is your collection. Row is a collection of generic untyped JVM, you can say JVM objects. Now it can also be your typed. So when we have a typed one, then that means we need to create some case classes, whether I'm using a Scala or I have to use Java classes, right? And here the data set will be data set and T. This is your type language. So when you see the data types, then you will see this data types T like this. So this is very, very important. Now, whatever the data frame we have done, we can also use with the data set, and the data, if the data is untyped language, then it will consider as a data frame, and otherwise it's a data set. But remember that we can only use Java and or Scala, not Python languages. Okay. So now let's see how we can create a data frame. So how we can create a data frame in this scenarios, right? So you know that in Scala, I'm talking about the Scala. So we have a val data frame objects is equal to spark dot read dot json, which we have done multiple times, and then let's say we have a one file called people dot json file is there. Okay, and I can call df dot show, and it will give me the default 20, and this is your untyped dataset operations. That means we have these are the df operations internally. Let's say we have df dot print schema, or we can have df dot select, and many of the operations we have already done. So just I am going to show you that these were the untyped operations. We can do that, but we can only write in Scala. So similarly, we can have df dot select dollar. We can also write like dollar, and then we can have name, and then age, and then I can add one this, and I can call show, and many more function I can do, like a group by also, right? So important thing is the data frame is, you can say, is an alias of your data set row, which we have done in many sessions. Okay, so now how we can create the data set. So now let's move to the data set. How we can create a data set? There are many ways, like we can do a transformation. So that means we can do transform a data frame. If you remember two methods I have told you. So you just transform a data frame to your data set using your as function. Okay. One way is this. Another way, you can using very basic approach like Spark session dot create dataset function you can call, and then you can create datasets also. And this will be basically from your local collection of objects, or you can also use 2ds implicit conversion utility. But we are going to see that how we can create with the help of case class. Okay, so we can also do with the help of case class, and I want to show you the demo for that. I'm trying to open the Databricks Community Edition. So first of all, I'll share my screen again. So just I'm using the Databricks on Community Edition. So just waiting for the logging into the system of Databricks. It is taking some time. So let me check the cluster is on or not. This is not on. I'm just declaring it as a cluster. I'm creating one cluster. I'm creating one notebook. I'm using the Scala, and this is your data set demo cluster. I'm using all cluster dead. So let's create it first, then we will check how it goes. So meanwhile, we can also check how the cluster works. Is it working or not? It is also not working. So let's create another one. My cluster availability zone, I'm just changing. Let's wait for the creating a cluster. So meanwhile, we can start with that. So first of all, if we want to create a data frame, first we need to use a case class. Okay, so this is a case, and I'm using a class because I'm using a Scala. You can also use Java also. Okay, so let's say, let me type the function called, let's class is your person, and then the class I'm providing two variables like name, which is your string, and let's say age is there, and I'm providing as an int. Okay, so this is your case class. After that, I'm using a variable called val. I'm creating a person data set. This is my data set name, and then I'm putting some data into that with the help of sequence. And in sequence, I need to call this person class, and I put the variable as a constructor. Let's say one variable is called nd, which is a name, and let's say age considered as 25. Okay, is the name over here, and 25 is the age, and another value I want to put, let's say person, and let's say Bob, and age is, let's say 26. Now this is the data we have, and I can create this data with the help of 2ds. 2ds function will create, and once the data set is created, I can call this data set dot show, and I can now execute it. So let's me wait for the cluster to run, then we can do that. So with this, you are able to see the two screens. So it is taking some time. So let's see. After this, I want to show you. Let me execute this part, launch and run. It's not running. And this, I want to add one more tag. So now let's see how we can also create this data set with the help of sequence. So let's say we have a val, and we have one variable called, let's say, my data set. Okay, and then I'm creating a sequence, and now sequence is 1, 2, 3, 4, and then I can also create this sequence as a two data set. So this is my data set, and now I'm going to write this dot ds dot, and I'm applying some transformation into that is a map, and in Scala I have, instead of lambda, I need to write x, and this is the symbol for, and I'm using just incrementing the value from the sequence file which is there in my data set, and then I can call collect or show function, but I always prefer to call my ds dot map x plus 1, and then we have a show function. So I'm more interested in doing this way. Now cluster is ready, so let me start, check my cluster again, connect to my cluster. If I execute this, you can see that first of all the case class is created. Okay, the class is created because in Scala we need to use a case class, and second, I have added a sequence where I have added two objects with the name Andy and Bob with the age of 25 and 26, and then I created with the help of 2ds function, and then I have shown this. So now you can see this is your data set. Now similarly, in the similar way, I can use the second one also. Here I have the sequence 1, 2, 3, 4. Then this sequence is created as a data set. Now this is become a data set. Okay. Now coming back to the data set, one interesting thing I want to share with you is that you can say either a disadvantage or a limitation, you can say, or limitation if you want, of the data set. And I want to highlight this, that not all the operations which are available will convert your data sets to your data frame. Okay, let's say I will give an example, filtering. So when you apply an operations and you call as a 2df, then it will not convert everything data sets to the data frame because of some of the operations are limited. So this is only the limitation of that. Now, very interesting questions comes arise. Why PySpark does not have data set? So now very interesting question arises, why PySpark does not have data set? Because we are using Scala till the prime, and Scala will show compile time errors whenever we have case class instantiated. Okay, so whenever the case class is needed, the Scala class can throw a compile time error. But in the Python, because PySpark internally uses Python, so Python is not having compile time error. You can say compile time, not having compile time type safety. So it will, what it will do, it will throw the error, it will throw the error at runtime. So it will throw the runtime as a runtime exception. Okay, so whenever we have the case class instantiated with some invalid argument, it will throw the exception at the runtime, not at the compile time. Because of that, it is not used in the data sets. And we can also say that the data sets API cannot be added to PySpark because of some limitations, because of the Python limitation. So this is the reason PySpark has not been used DS till now. If there are some changes future, we don't know, like might be in some coming Spark version, we are able to see that, but Java and Scala support the dataset very well. So guys, this is about the data sets. Thank you very much for having this session.